Yo, yo, yo. Is that right? Is that what you want? Okay. So here's a pyramid. It's had the top part cut off. The top part that is cut off is actually another pyramid. So the volume that this cone is a third times the base squared times the height minus a third times this 20 squared times 20. Does that make sense? But because the base and the h are the same, then you've got this a third height cubed minus a third times 20 cubed. So that is the volume of this shape just here. You guys happy with that? Okay. What we've been asked to do is find the rate at which the surface area of the water is increasing. So we're asked to find dA by dt, aren't we? Now, as I said to you guys before, when I looked at this question, the first thing I was doing is trying to figure out the surface area, which included the sides and the bottom as well. But as you guys interpreted, the surface area is just the top part, the top level of water. It's just that part there that they're after, which has just been rubbed out, like that part there. You guys happy with that? Oh, can we do a nice picture? You guys are hopeless. Like that. Yeah? What shape is that? Okay. So if that's what I want, I need to have this dA by dt, don't I? Because this is a related rates of change question. That's what I need, isn't it? The question is giving me the rate at which that's a volume, isn't it? That's dV by dt, is it not? So what I need here is dA by dV, do I? Are these to cancel? So you're trying now is to figure out, have a function between area and volume. You're trying to figure out an expression that relates area and volume. Now, to me, that's going to be real hard to figure out. So this is not right. This is not right. It's one of these ones. Okay. Now, because what's the volume in relation to? We've got this height function, eh? So we could find dx by dv and dA by dx. We can find out which, because that's just a square you guys said, wasn't it? Yeah. So the area is just going to be like x squared, and the volume's going to be like h squared. We need to make h the same as x, and then we're away laughing. Okay, so this was wrong. Now, what? All right. Okay. Is that there right?
Yes.
What does x represent?
8.
No, what does x represent?
Sides.
No. It represents the height of the water, I suppose, isn't it? Is that right? No. Just there. If there's h, x is the height of the water because it's talking about the rate at which it's changed. So it's just talking about that part there. So in other words, we've got h is the same as x plus 20. X plus the 20, and there's our height. Can you see that? That's probably the hard part of that whole thing. Once you've got that, because the area of that surface area to the water is now that. Okay, you happy with that? Can you see the difference between h and x there? a lot of blank faces. Can you see the difference between h and x? That's the key thing. Okay. That h in there now, volume is a third of x plus 20 cubed minus a third of 20 cubed.
Does it matter if you do it in x or h's? Like,
Well, it
yeah,
does later on because
like you could have written that x equals h minus 20.
Yeah.
And then put it all back like that.
Yeah. No dramas like that. Okay. So dA by dt then. dA by dx. What's dA by dx? Happy with it being just 2x plus 20? dx by dv. We need to differentiate dv, don't we? I'm running out of space. So dv by dx is x plus 20 all squared. Happy with that? A third times a 3 makes it 1. Yep. So that's going to be 1 over x plus 20 all squared.
No, what about the minus third 20 cubed?
Well, that's just a constant. That's just 8,000 divided by 3, which is just a number.
Why is it 1 over?
So when you differentiate a constant, 2x plus 1, what happens to the 1? It disappears. Happy with that?
Oh yeah. Oh yeah. Sorry.
Sure.
Why is it inverse?
Because this is
Gotcha. Yeah.
dv over dx. Yep.
Yeah,
So we need,
yeah.
yep. Okay. And the last one, dv by dt, is 3,000. Okay. Now, all of that, 2 times 3,000 is 6,000. X plus 20 all over x plus 20 all squared. What can I simplify that any further?
6,000 over x plus 20.
Cancel one of those ones and you're left with 6,000 divided by x plus 20. Now it says here find the depth of water is 15. So this is where, if you've used Sam, if you've used H,
Yep.
you have to figure out an expression for H. I'm using the depth of water as 15. Can everyone see that now? X is there. Talking about the depth of water. So this is now at x equals 15. dA by dt is 6,000 divided by 35, and get your answer. Plug it into your calculator. 171.4 cubic centimeters per minute. How do I get cubic centimeters per minute? Pardon? Sorry, square centimeters per minute. Sorry, yeah. Centimeters squared per minute. How do I get that unit?
Because it's the surface area.
Because the surface area and area is squares rather than cubes. But because that is centimeters and that is in minutes, that's where my units come from. Okay, and these here, all my units are in centimeters, and the rate was minutes. You guys happy with that? Does that seem like that's hard, eh?
We have to go back and watch the video on that.
But what's the key part about it? What was the key thing?
Understanding what
I reckon the key part was, and this is maybe where Ichiro, this is what I was trying to take for you, was what are you asked to find with this question? It asked you to find the rate at which the surface area is changing with respect to time. That's what you are asked to find. Okay, and so with these related rates of change questions, I reckon you need to try and set up that equation like that. Now, if you're asked, does everyone understand that part there? That's what you're asked, eh? Can you see how I write that next part directly from that then. And you're always going to be given this part or this part. Okay? Now, on this particular question, you are given dv by dt. And so what you have to try and do then is that should go there. Like that, shouldn't it? When you figure out these related rate of change questions. But therefore that there, it's just too hard to try and link an expression between the area and the volume. So what you do then, because you can just insert these other two to make it a bit easier for yourself. I'm trying to help you decide whether or not it's an easy related rate of change question, where it's just like this, or if it's potentially the harder one, where there's 3 or even more involved. Okay, and the way I would do it, it's me, and I know whatever, this here is the way I'd do it. I'd try and set up that equation at the very start of my problem. Try and set up that equation. And if I get stuck in here, I'm probably going to try and see if it can easily be related to one of these two. Does that make sense? Is it or not? Yeah?
Yeah.
Okay.